Alright. We should be live. Guess I need to double check that. Dun, dun, see. Okay, looks like we are live. I think I want some music though. Gosh, I still haven't figured out the rules around how I can basically have one how can I have music playing as I'm streaming. I haven't looked into it. I guess my guess is that there's a category of music that I can play and some that is off limit. I will get my we'll get the video striked or whatever the wording is. Who knows? I don't know. This whole streaming thing, I'm still I definitely haven't spent time really looking into the production side of things. But anyway, so per the title, we'll be looking at the Turso SQLite rewrite, codename Limbo. I don't know if it's a codename at this point. It's just the name of it, I guess. Yeah, Limbo, a rewrite of SQL in Rust. Particularly, we'll be focusing on the simulator aspect or component or module, whatever we want to call it, in the code base. So yeah, that's what we're gonna do. In the meantime, before we start that, let me see. I don't know if you guys will appreciate this, but I'm in a process of actually learning how to properly type. Also with one of those funky keyboards, the Advantage Kinesis, the Advantage 2. So I think I'm gonna do a little bit of practice, maybe for 10 or 15 minutes. Have some music playing just to kind of wake up the brain. Let me see. Let me log in off screen. What's that? Okay, it's keyboard. I'm gonna sign in. Yo, I need some music. This is too quiet. I need some chaos. Let's see. Can we do this? I doubt it. I was gonna play some Hans Zimmer from Dune, but I don't want to risk it. Let's see. Can we play one of those weird I don't know, they call it binaural bits or whatever. I never did any actual research to know if these things are even remotely effective in any way. This is, gosh, I'm having a hard time pronouncing this. Tchaikovsky. Alright, let me sign into the thing and then we'll do some touch typing. Actually, I am I oscillate between doing some touch typing and some Vim motion thingy. So I don't. Should I do typing or Vim motion? Oof, okay, this is a little too loud. The music. Okay, that's better, I think. Alright. Practice. Alright. Actually, you know what? I'm gonna cheat to make this interesting. Well, I don't know. Should I do it? Like, have some sort of video in the background for that I can maybe comment on. You know, like I think Theo just put out a video about rate limiting.
Rate limiting is hard. There are some quick solutions.
Yeah, okay, let's do that. Why not? Everybody's a reactor now, apparently. Isn't that what the hot thing now? It's either AI or you're reacting to something. Wait, no, I don't need the whole thing here. Okay. Come on. Yeah, so over the past several days, I've noticed that my Mac Mini was being sluggish. So I basically turned it off and now it's, it's worth how much I paid for it. Or at least it feels like it right now. Which, I don't know if you were on stream yesterday or you watched yesterday's stream. It didn't feel like it. It didn't feel like I paid how much I paid for it. Okay, so how am I gonna do this? Okay, let's see. Let's maybe shrink this like that. Oh, yeah. And maybe have that up here. Let me see, how does that look? Yeah, it looks alright. We can live with that. Alright.
But as a problem overall, this is a complex topic, and I'm really excited that a community member actually wrote an article about it. I've been wanting to read this one for a while, but we're finally getting the time to do it. Let's take a look.
Yeah, I'm probably gonna 2x this just because. Although there's this thing here that I started that I think I will love to finish. Well, I probably couldn't finish it, obviously, right now, but it was really interesting. It was about graphics programming. I just need something to play in the background, I think. Yeah, let's
visualizing algorithms for rate limiting. Why rate limit? Imagine a Twitch chat with many active participants and just one spammer. Who could ever imagine that? Definitely not an experience I've had before. Without rate limiting, the sole spammer can easily dominate the entire conversation. With rate limiting, however, each user has a fair chance to participate. Yep. So right now, the spammer is sending tons of requests, and every other user has some going in, but you can barely even see them in chat. A rate limiter lets you control the rate of traffic that your service is processing by blocking requests that exceed a set limit during a period of time. So think of that like you have every 10 seconds you can send one message. There's actually a setting for that on Twitch where I can do chat settings, slow mode, which is effectively rate limiting built into Twitch so that when I check one of these options, then you can only send a message every 30 seconds or 5 seconds or however often I choose, which helps keep it so that individuals can't spam chat quite as hard. They even have some good examples here. It's useful beyond just throttling spam and chat. Like if you have something like a login form, you don't want people to be able to brute force and just spam until a password gets guessed correctly. So every time they try to get in, you limit how often they can do it. I was actually trying to get into a site yesterday. When I signed in, I typed things correctly, but it auto hit enter for me effectively when I used one password. And then I hit the login button. So it sent 2 requests instead of 1. And I got rate limited and I wasn't allowed to get into my account for another 2 minutes. But that's terrible as a user experience, but also important because it means people can't just spam passwords over and over to try and break into your account. API endpoints are also frequently rate limited to prevent any single user from monopolizing resources. Imagine that you want users to only be able to hit an expensive endpoint 100 times per minute. You can track the hits with a counter that resets every minute. Any request after the 100th within the minute would get blocked. This is one of the simplest rate limiting algorithms called the fixed window limiter. And it's a common way to control traffic to a service. Yep, very, very common. I use this in a lot of the things that I've demoed and the products that I've showcased in my tutorials, in my previous videos. Using something like Upstash in their rate limiting SDK lets you set this up with like 3 lines of code, and that's enough for a lot of things.
That sounds like some product placement.
As they say,
right
it's not always
there.
that simple. When does each 1 minute window begin and end? If I begin a burst of requests near the end of a window, can I exceed the limit? Is the window's capacity restored 1 request at a time, or is it restored all at once? In this post, we'll explore the 3 most common algorithms to answer each of these questions. I actually don't know the immediate answer for this, which is interesting. The 3 options are fixed window, sliding.
Oh, okay. Well, it's right there. I was gonna answer it, but shit. Okay.
Window in token buckets. Let's figure these out. Here's the fixed window example. A set number of requests can be made within a predefined time window. Requests increment a counter that's reset to 0 at the start of each window. So notice that this time window starts regardless of when you send something, regardless of when a request happens. This window is an existing time frame that just exists via something like a cron job. So we know this happens within this window, and then messages happen to be sent. You can pause requests and see the window stays exactly the same, even with no requests happening at all. I can also spam hit and see the result too. This is a really nice visualization. What are with all y'all insane devs and your crazy visualizations lately on these blog posts? So cool. So yeah, the pros of this is simple to implement and understand and it's predictable. Predictability is not necessarily a good thing, as I'm sure we'll get into. The con is that this allows for bursts up to 2x the limit. So yeah, if we're getting near the end here, then once we get close to the end, I can spam and then immediately start getting requests going through again. So you actually can do really bad damage in those short windows because you can up to 2x the damage in that frame. There's a real world example of GitHub's API, which uses a fixed window rate limit of 5,000 with a duration of 1 hour. And the start is set to the start of each wall clock hour. So every user is allowed to make about 5,000 requests per hour to the GitHub API. So if you make 5,000 at right before midnight and then 5,000 right after midnight, you're fine. But then the next request is what fails. So you can still send 10,000 requests to GitHub in a 2-minute window. You just have to do it at the right times, which is a real risk to consider when you're building things like this. Ooh, there's a tangent about 24-hour windows. Ooh boy. Apparently there's a subtle issue with the 24-hour limiter above. Its window resets every day at midnight, but midnight according to which time zone? A standard fixed window might reset its counter according to your server's midnight, or a standard time zone offset like UTC. A user in a different time zone who ran out of requests might retry just after midnight and be surprised that the limit hasn't been lifted, since to them, it's a new calendar day. For these applications, you need to offset your window starting according to the user's time zone, which has some potential for abuse as users can manually adjust their time zone once they've run out of requests, gain up to 1 full window of additional requests. Yeah. I don't recommend doing a 24-hour window, certainly not sharing that and telling people that the requests restart at midnight. Yeah. Not like Twitch does that for certain features and things like the tracking of how often you stream. It's not like the best way to get partnered on Twitch fast is making sure you stream between 4 and 6 p.m. Pacific time, because that goes over the 5 p.m. window where they count it as 2 days instead of 1. Those totally aren't things. Interesting. Another way of doing fixed windows, which is how a lot of things will do it, is instead of fixing the start time on a set interval, each window can be created at the time of the user's first request within that window. So now, if I hit pause, nothing happens. Still nothing's happening. And the window that's 24 hours doesn't start until I do a hit. So now that I've done one, I can do up to however many this allows. I have 1 request left. And now I get errors until I do one after that first one's been 24 hours. So the window shifts based on not if it's midnight or not, but based on when your last, or in this case, first request was. But this sucks as well because now I can get more requests if I start at 23. So I'm starting now, and I was able to do more requests. But if I wait and I do nothing, so I'm just sitting here doing nothing, we're going past the window. Now I'm going to start spamming. I can only get half as many. So it's actually strategic to do a request every 24 hours so you can exhaust that existing window before starting the next one. As insane as that is, so is doing your rate limits in this way. Yeah, as the author says, it's especially important to show users the time remaining until the next window once they're limited, since there's no set time that aligns with those windows. Speaking of aligning windows, sliding windows. Instead of refreshing the capacity all at once, sliding windows refill 1 request at a time. So here we see there can only be 5 requests. The way showing this is vertically. So if I pause, right now we've done 2. I can do 3 more, and now we're going to have errors because there's no space in that vertical real estate. It's actually a really good way of visualizing how this works. And you can see they go gray once that request's limit has expired. So instead of thinking of this as like you have a buffer of how many requests you could do, each request has an amount of time it exists for, so to speak. And once 5 requests have that timer overlapping, you can't make more at that point. Well, 6 here. But now I can't do more because the spot's already taken. But as soon as it's been 24 hours since that first request, then I'm allowed one more, then another, once it's been 24 hours per request. So that's a sliding window. The benefit of this is that it smooths the distribution a bunch and is well suited for high load, but it's also harder for a user to understand and predict, and storing the timestamps for each request is obnoxious to do. Totally agree. Yeah, if you do rate limit, send a retry after header. Very much agree. You can see what that is with the MS or the MDN web docs, where you can have a 503 or a 429, which tells you as the user hitting the service that you've sent too many requests and to wait until you make a new one. And there's even a retry after header that you can send that can either be a date or a delay time for how long you should wait until you try again. Back to sliding windows. Because sliding windows tend to be most useful in high traffic scenarios, the fact that the naive algorithm is resource intensive is counterproductive. Shouldn't a high traffic rate limiter use an efficient algorithm? For this reason, most real world sliding window rate limiters, like those provided by Upstash and Cloudflare, they all use an approximation, often called a floating window. Using this approximation, we have all the same benefits, but we can remove the resource intensive point from the cons. Here's how that works. Yes, Upstash mentioned they do these things well. You can count the number of allowed requests in the previous fixed window. You can count the number of allowed requests in the current fixed window. You can weight the previous window's allowed request proportional to that window's overlap with a floating window ending at the current time. And then you can add the weights from 3 to the unweighted results from 2. So if we see how that works here, we have this imaginary window that exists that knows what requests did or didn't happen. And it can use the average between that window that's just last 24 hours and the window that we're in right now in order to make things a little more reasonable to understand and to give users a rough guarantee of when they'll finally be allowed to do things again without having to store all the same data. In practice, this approach limits requests at roughly the same proportion, but it's far more efficient than tracking all of the requests' timestamps. While the two algorithms will end up blocking different requests, the long-term average number of blocked requests should be very close. You can see below how it compares. I'm going to pause and do the hits all myself. Yeah, it's literally just taking how many hits exist in these two sections and just averaging them based on how much you're in any given one section. So if we were to spam a whole bunch at the end of one of these here, like that, it's going to weight heavily on that left side because they're all near the end. But if I spam them all at the beginning, I should be good to go pretty soon, but I won't be because there's just so many messages that are backed up there. And it is counting the ones that are outside of that little box because it's just averaging the amount of messages in the two boxes and using the split of how much each box is currently in view. It's hard to describe, but it is actually a really good visualizer for it. If I spam this one, so we have all these messages at the start there, I'm not going to be allowed to send more messages right when we get into this new box because even though we only have the second half of that box in there, it is still averaging using the values from the whole box. So that's the key here, is how recently or not recently it happened. It doesn't matter. It just matters which window it happened in. This is a really good algorithm for this. And apparently this is how Cloudflare's rate limiter works. They use an approximated sliding window. Good stuff. Token buckets. People in chat were already bringing this up. Let's see what we have to learn about tokens. Instead of thinking in terms of windows with durations, picture a bucket that fills up with tokens at a constant rate. Each request withdraws one token from this bucket, and when the bucket is empty, the next request will be blocked. The token bucket approach has some useful properties. The first is that the capacity of the bucket is the maximum number of requests that a burst can possibly support, not counting tokens being replenished mid-burst. The other point is that the refill interval represents the long-term average of allowed request interval. Having distinct bursts in average capacities without the need for multiple rate limiters is one of the main benefits to the algorithm. So here we see, it's actually a really nice visualizer. I'll pause so we can do the request manually. This is the request, and we get a new one added to our bucket every, in this case, we have 6 requests, 24 hours, so every 4 hours? That sounds right, math is easy. So every 4 hours, we'll get a new request in the bucket up to 6. And I fired one, and we just happened to be near that 4-hour mark there. Now we'll see every 4 hours, we get another request added to the bucket, but if we run out, we can't do any until we get one more of those. But the interesting thing here is we get one more request, and then we can't send any for a bit. Then we get one more, then we can't send any for a bit. Good stuff. The pros of this are that you're allowed to do burst traffic really well too, while still having a long-term average. It's also more flexible, which allows for traffic spikes within acceptable ranges. That's also really nice here, because if I can do a higher maximum because I don't have to worry about the doubling problem, because you can't brute force 12 requests here the way you can in any of the others. Especially the traditional fixed window, it's really easy to do things in a way where you have 12 requests really tightly coupled. So if I go back to the top example up here with the fixed window, I'm going to spam a whole bunch through the end, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. Within a very small window, I just snuck in 12 requests. If we have the fixed window with a user-defined start, I can do one request, wait till near the end, and then now when we're getting to the end, I can spam that last 5 and then do another 6. That lets you get 11 in that really tight window. So you can get effectively 2x what you set your rate limit to with these options. With sliding window, it's a little bit harder, but you can still kind of do it. But then with the tokenized version, you can't. The user can't send more than 7 requests relatively quickly. And that only happens if they're near that renewal. So 1, 2, 3, 4, 5, 6, 7. Yeah, cool. And that's it. Now I have to wait another 4 hours so I can do another. So it makes it much easier to define, like within this window, there's a maximum number of requests that can happen. But the big con is it's really hard to explain this to users. So you can't just be like, you can make requests again at this time, because they can, but probably one request. So how do you communicate them when more of these tokens get fulfilled? It's a tough challenge. Apparently this is how Stripe does things. Stripe uses a token bucket in which each user gets bucketed with limit 500 and a refill interval of every 0.01 seconds. So you're allowed to do a sustained activity of 100 requests per second, but a burst of up to 500 requests. Really good to know. OpenAI's free tier for GPT 3.5 is limited to 200 requests a day, but uses a token bucket with limit 200, and it refills on 86,400 seconds divided by 200. So you get a full bucket every day, but more importantly, math is hard, you get a new token every 432 seconds, which is every 7.5 minutes, roughly. The Twitch chat demo above is rate limited using a token bucket with a bucket size of 3, allowing bursts of up to 3 requests, and a refill interval of 4 seconds, which creates a long-term average allowed rate limit of 1 message every 4 seconds. For what it's worth, Twitch's slow mode is just doing a fixed window starting when the user sends. So I send a message, now I'm not allowed to send another message for however long that is, and that's per user, because we already store timestamps, so we don't care. Thanks to the flexibility of the token system, token buckets can also mimic the properties of some of the other algorithms. For example, you set the refill rate to be equal to the limit, and now you have an equivalent to a fixed window rate limiter with a user-defined start. Yep. I don't think I can turn off the automatic here. Oh, it's constantly going. Yeah. So if you refill the bucket every 24 hours after a request has been made, you effectively have a fixed window again. Good stuff. Didn't think about this as a way to re-implement all the other solutions. Kind of like how in React, all of the hooks are for the most part just built on top of user reducer. Like useState is just a user reducer under the hood. Fun fact. Other considerations. If you decide to add rate limiting to your app or endpoint, in addition to selecting an appropriate algorithm, there's a few other things that you should keep in mind, like creating a persisted store for that rate limiter. Yep. If you're trying to scale a rate limiter across multiple servers providing the same thing, you need a place to actually store the information.
I
If you ever
knew
need to
it.
horizontally scale your
This
server,
is
or you
a
need to start it from
long
serverless,
commercial
also important. If you're serverless,
for
you just have a
Upstash.
variable you need to store it somewhere. Your rate limiter data can't be in memory. Popular option is to save rate limiting data to a key value store, like Redis, which has built-in functions for expiring keys on a
it's
separate machine from
coming.
your application. You can, however, use an ephemeral in-memory cache to block requests without hitting Redis while the limiter is hot. This is already what's being used by something like the Upstash rate limiter SDK, so just use that. This is handled for you, but good to know. You need to make sure this data is stored somewhere, so if the server goes down for a second and comes back up, it has the
I
context.
was like, wait,
Also,
why
failed.
is
Your server's connection to the persisted store
why
failed.
is he
Make sure
just
to allow all requests rather than
choosing
blocking
to
access to
do
your
a
service altogether.
video
Also
on
important. If the Redis service goes down, you shouldn't block all requests. Ideally, you're letting everything through temporarily. DDoSing your
this
Redis is
is
way less
a-
bad than
this
DDoSing your
is an
actual database, like
Upstash
exponentially so.
commercial.
Also, optionally throttle bursts. Throttling can be used in combination with rate limiting to reduce the impact of burst traffic. Very good piece of advice. If you can throttle things, then that solves your problem.
Which
Probably worth
is
doing that.
fine,
Then you have to fail
I
requests.
guess,
Also,
if
choose
it
sensible
solves
keys.
the
In general,
problem.
rate limiting is done on a per user level. For most apps, this means keying on the user ID. For APIs, the key could be the API key. What they mean by key here is how you identify what user is being rate limited or what process is being rate limited. Because if I have like a rate limit for signing in and a separate one for hitting my API, you need a key to identify which is which, and that needs to be unique to the user. Because I don't
Oh
want
my
all
gosh,
users rate
I
limited for
lost
signups.
my
I want
flow
one user or one IP
completely.
address rate limited.
Oh
One of the best things to
God.
do here is just use like an IP address. They even mentioned that here. For unauthenticated users, the options aren't great, but a popular method is to use the requester's IP address, or a device fingerprint, or a unique installation ID, or just some type of shared limiter across all those users.
Completely.
You can also
lost
surface
it.
useful rate limiting errors, which you really should if you can. As we mentioned before, use a 429 HTTP status code when the request is blocked, and include the relevant X rate limit response headers.
slow
GitHub has a good
down.
example of the header for their fixed window limiter, and OpenAI also has some examples for their token-based limiters. This all means that when you hit something, you do hit the rate limit as a developer consuming one of these APIs, you can look at when it says, okay, start again now, and just delay until then. Wrapping up, you need a simple rate limiter or predictable window start time, use a fixed window. You need traffic smoothing for high volumes of requests,
slow.
consider the approximated sliding window. But if you need to support bursts of traffic while also enforcing a lower average
Pinky
long-term rate limit
hurts.
for requests, use a token bucket. This is great.
What's up with
See a bit of fun
that?
playground at the bottom here where you can see how all of the different things handle different types of traffic. I love this. This really is like a Sam Who article, but not by Sam. Oh, it even says that here. Pre-read. This post is inspired by the amazing load balancing visualizations that Sam's done for his stuff. Also, a huge thanks to OnSquam for pairing with me on the Canvas visualizations. And also a thank you to Upstash for their docs and implementation stuff. This is great.
Maniple.
This is awesome. Is the author's name somewhere here so I can shout them out? Or is it just like the company? I wanted to find out who this actually is. Does anybody know who this is or their Twitter? Bone Broth. Was this actually you? Shit. I didn't even see you in chat before. My bad, Bone Broth. Is there a Twitter I can shout out for you? Give me a Twitter if you have one that I can shout out. But if not, totally fine. This was great. Thank you so much for this. You don't have Twitter? That's for the better. Do you at least have more blog posts? These...
We could actually we could do this one. You can already you can already see how much I struggle. Whenever you start to see these print statements start to pop off like crazy, yeah, it means that like it's not going so swell. Okay, so let's take a 1 minute. I'll just
It's this deep ML. Oh. Is this like the lit code of deep learning stuff?
just got out of the winter. Okay, cool. So let's read the problem statement here. So write a pattern function to calculate the correlation matrix for a given data set. The function should take in a 2D numpy array x and an optional 2D numpy array y. If y is not provided, the function should calculate the correlation matrix of x.
Most of this is
It
linear
should not
algebra.
return the correlation matrix. It should return the correlation as a 2D numpy array. Okay. So that's good. I don't see like what is difficult here.
Statistics. How much of it is statistics?
Okay, so if y is none, we're doing something. Otherwise, we're doing something else here, right? Okay, and let's learn a bit about this topic. So a correlation matrix is a table showing the correlation coefficient between variable. Each cell in the table shows the correlation between two variables with value ranging from -1 to 1. The correlation coefficient between two variable x and y is given by this.
Didn't know this was a thing until just now. Deep ML. Might give this a try someday. Alright. I think now I'm just gonna play some music, do a little bit of typing, and then we'll start reading some code.
Great. Thanks for having me. Hope everyone can hear me okay and see this.
Oh, I can. No. Come on now. Don't do this. Context in this one too. Resist the urge. Come on. Let's just play some video. this one is don't know if I'm doing something wrong, but my left pinky actually kind of hurts. Start over. I don't know, maybe I need to adjust my hand placement. I mean, it's just the fact that just typing these specific symbols just requires using a lot of the left pinky. Still struggling with transitioning from letters to numbers, and then you have the symbols in between. Yeah, I need to look into this because I don't think it's supposed to hurt. Like, it doesn't hurt, but it's there's definitely some discomfort at this point. And with the standard typing, it just, hurts. Which kind of defeats the purpose of getting an ergonomic keyboard. Maybe it's the force with which I type. But I mean, how can you really control that? It shows that there's a lot of shift to use. I don't know. Yeah, there's no way. At the start of this year, there's no way that I could have typed at this rate on this keyboard. So we're making progress. I think I would like to go twice as fast. Okay, maybe not literally twice as fast, but close enough. I actually don't know. I mean, how hard is it to type 100 plus words per second with programming symbols like this? Like, genuinely, I wonder, how do you get to that level? Especially if you've never really learned how to touch type early on, like me. Okay, maybe let's make this the last one. Ay, ay, ay. I should do some crazy shit like stream. I'm going one-stop stream until I hit some sort of speed, and I'm able to repeat it without any errors for like 3 rounds in a row. Gosh, that sounds like torture. Yeah, I don't think I'm gonna do that. At least not at this point. I'm gonna lose my mind. But I bet if I did, there will be some Mr. Beast type challenge thingy. At least in nature, I guess. Not in terms of okay, last one. Can't do this. Oh no, already. Alright, that will have to do for now. Alright. I don't know. I think this music is supposed to keep my mind focused, but I feel like it's maybe trying to put me to sleep. Maybe my brain is fucked up like that, but I don't particularly feel like super focused or anything. If anything, I'm feeling a little let's try this. Come on, come on, come on. Actually, I just got an idea. Limbo. Simulator. Deep Wiki. Talk to me about the simulator. Just gonna put this to the side. Make this wider. Okay, let's see what Devin says. Oh, just keeps on going. Okay, wow. simulator is sophisticated testing tool designed to verify the correctness of the Google database. Generates random but reproducible database interaction plans and execute the test detecting issues related to concurrency, handling, and edge cases. Call components, main entry points. So it's the simulation coordinator, or the model, simplify representation of the database. Create a random database interaction sequence. Creates random database interaction. Does it create? First question on this question. Question that comes to mind here is the when? Are these generated JIT, like in the JIT manner, as in just in time after each simulation step? Basically, is it dynamic or is it, static? You generate them and then you do the simulation. Different testable property about how the simulator works. So it's with wait. Okay. How the simulator works. The simulator follows the general workflow. It starts with random configurations for workload distribution, database parameters, and other settings. Okay. Based on these parameters, it generates interaction plans consisting of SQL statements and assertions. It executes these plans against the database and verifies the assertion holds. If a bug is found, it can shrink the test case to find the minimal steps needed to reproduce the issue. Interaction plans are the core of the simulation. They consist of SQL queries, randomly generated based on the workload distribution. Which part is actually random, I guess. We'll see. Executable specification about expected database behavior, any other assertions. Properties are a key concept in a scenario that represent executable specifications about database behavior, for example. Some examples of properties include insert value select, verifies that inserted rows can be retrieved with a matching select query. Double create failure ensures creating the same table twice produces an error. Okay. Checks the limit the limit clause are respected. Running the simulator. Sim debug. Okay. Actually, do I have Rust? Oh no. Oh, okay, I do have SEO stuff, so that should be okay. Let's see if, let's just try it and see what happens. What happened? Lemon Malak? Bro. Bro. Well, that's not good. And is this like a dependency that's missing? Lemon Malak. Let's see if I can convince this guy to fix this. Simulator. If I want to do that. Okay, so I do have it installed. Be 15.2 then, right? Yeah, I can run it. Lots of warnings. Man, I don't want to do all that. I just want to read some code right now. I mean, I have Nix installed, but not on this particular account. So usually when I install things through Nix, I do it in the main account on the computer, and the other accounts inherit from it. So this particular account is for streaming. You know what? Let's just skip this for now, because I don't want this to get in the way. Although it would be nice to be able to run the thing as part of reading the code. Whoa. Yeah, so next thing is influencing the build because because I'm using Nix from the main account. This is annoying. Yeah, you know what? Yeah, we'll have to skip this because I still want to get through some significant amount of the actual code base to really start building a mental map of everything. So this deep wiki stuff actually helps with that quite a bit so far. Okay, this makes sense. So differential testing. Supports watch mode. That was the simulation when the files changes. Interesting. Bug detection is shrinking. When the simulator finds a bug, it can shrink the test case to find more steps. We need to reduce the issue. Execution flow. Okay. So we have testing main function. Okay, so it's here. A bug database. Bug errors. Is that just a list of things to check against? Runs either differential testing or standard simulation based on options. Reports results. Actual simulation is run by run simulator function. Simulation environment. So this parameter is all set randomly, but I bet there's some sort of like it's not 100% like completely random. There's probably some sort of guiding principle for generating a subset of the full domain of possible values. Okay. Yeah. Okay. Let's look at the code from here. Just gonna leave that one as a chat history. Alright, simulator. Excuse me. So in terms of dependencies, we have clap, generation module, there's some sort of randomizer, runner, and a bunch of standard library stuff. Alright, let's see. I think I'm gonna have to leave it to be as big as this. The problem is I also have my big ass head in a way. That should be fine for the most part. Yeah. Okay. Alright, so we have all these modules. Path buff. All the paths. Okay, so by default you can just, well, not by default, but one options for the factory of this thing is that you can just use it as the same folder for all of them, for all the paths. Okay, so main. I think this is some tracing stuff. Well, obviously, but like open telemetry, I think. Well, they don't even mention it here, but I will be surprised if it wasn't that. Anyway, so we have the man, we have a simulator for the CLI. No, the CLI simulator. No, the simulator CLI. Okay, so now we need to validate this. What does that actually entail? Mutable reference, we check the minimum test, maximum tests. Minimum shouldn't be bigger than max, that's common sense. So this is how you remedy this particular violation here. They will also check if to avoid duplicate work, right, and avoid unnecessary gosh, what was my brain just circuited for a little bit there. Trying to understand why. Cannot set seed and load plan at the same time. Well, I guess because loading the plan is supposed to be separate from the actual, I guess, the actual simulation run itself. And I think the seed gets generated right as the simulation is about to be kickstarted. So that's my guess for that. Alright, matching on the subcommand, if it's a list. Bug this, list bugs, okay. Loop. What are you looping over? This is annoying. Oh. Okay, we're back up here. But this is a printing thing to standard in. Well, that's more standard out. Okay, so for, and I'm guessing that's the number of iterations in the loop, or at least for bounds checking. So for each iteration, run testing main. Result is error. If there is an error and short circuit is on, which means really get out early. As soon as you notice that something does not add up, you just bail. I think it's commonly called fail fast. Okay. So that's one. Then there's test. Is that one for? Guess the oh gosh. Gosh. Completely forgot what I was gonna say. Well, that's annoying. Okay, so simulator subcommand test. Wait, let's see. Okay, so we have running the loop, simulator in the loop. Yep, it's a state machine. You just keep spinning for each step, and then you inject whatever information you need to inject into the context environment. Anyway, default value. And then we have list all the bugs in the base. And the simulator. Run the simulator with a previous bug you run for the specific field. Wait, what? Okay. Sets for reproducible runs. Double check it, just run things twice. Pretty straightforward, I guess. Okay. Where was I? I think it was simulator. I think we're supposed to be in main. Where is in the simulator? Okay, so if you go test, pass in your filters. There's a database of bugs. We load that. If something happens, we basically bail here, I think. Yep. Okay, so we have the list of bugs, and what do? We flat map each item. So runs filter Sorry. But now I'm curious. Why not just use filter map here as well? you get your runs, and for each item in run, you use that to basically control the testing run. Set the CLI options. And then this. So, okay, so we are sorting and deduplicating. Just wanted to change the sound for a little bit. So these are all the results of actually running the simulation. Separating from successes from failures. This is where the magic actually happens in test me. Sure, let me see what does the outline say. So again, we load the bug base. Wait, didn't we already load it somewhere here? Okay, so I guess we're loading it again. I guess I was just thinking, maybe there's work that's already done to load the bug base. I mean, there was. So here you loaded or at least you loaded the bug base here. Also, why do we need a mute for this? For the bug base, are we making any changes to? Let me ask. Why do we need this? Why do we need an exclusive lock for bug base in this execution branch? What is this? Oh, okay, so that's what it is. So this is why we need the mutable self, or the mute, the exclusive, the ability to take an exclusive reference, which is what's happening here. So the bugs are indexed by some sort of seed. Wait, so what's the type of the bug? So it's okay. Wait, why would it be the seed? I feel like you need a better name for that. No? Oh, a runner has been okay. All right. Never mind. I guess for a moment there, I just assumed that. I guess I'm wrong on that one. For a moment there, I just thought that you have a run and it just runs and collects whatever bugs it happens to come across. But no, if I remember correctly, and I guess this makes sense. No, it actually exits on the very first bug it found. So then you're able to classify that particular bug, or at least in this case, index that index that bug per its random seed. Okay, so now I know why we need a mutable declaration here. Okay, so we take the bugs. So these are previous runs that resulted in a bug. Okay. And for each one of them, so a bug has runs. So for each seed, so what does load bug do? Returns a loaded bug which has multiple runs. Okay. Where's a bug run? So wait. You can use the same seed, but wait. So how do you end up with multiple bug runs? Oh, I guess you can run the same test with the same seed, but on different versions or on different versions of the code. I mean, that makes sense because then you can track like that'll be a way for you to verify that you've actually fixed the bug from one code commit to another. In fact, this also allows you to know, or I mean, it's a means by which you can figure out when a bug was introduced, because you can technically go, I mean, if you're being judicious about this or elaborate about this, once you find a bug, you then run multiple, I guess, middle out really, to discover the range of commits for which this bug is applicable. Hopefully, you're not in a situation like the fsync debacle in Postgres, right? Where it's like, I think it's been there for, if I remember right, it's like a decade or so, or even longer. Fsync gate, Postgres. I want to know how long it's been there though. That's 20 years. Yeah, 20 years. So hopefully you're not in that situation, because if you're truly trying to figure out when the bug was introduced and you don't really have that much, like you're completely new to the code base, it's almost like a black box, and you really are trying to figure out, okay, when was this introduced? Now imagine having to track commits all the way to 20 years to now be like, okay, this bug actually applies all the way back to this commit. So anyway, so all right, so multiple runs for a loaded bug. So a bug run has a hash timestamp of the run, makes sense, in seconds. UTC, and the specific CLI options that were used. So a bug is either loaded or unloaded. Okay, wait, how did we end up in bug base? Okay, we were here.
Now I am become death. the
Destroy
destroyer
your
of worlds.
worlds.
I suppose we all thought that.
Gosh, the ending of that movie. When he stares into the... Was that a lake or a river? Who cares? That body of water. That was an epic ending. Well, and dark. Very dark. Ending. Anyway. Okay, so runs. Wait, let me see. Da, da, da. Da, 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 da. Da, 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 da. Da, da, no, clicked on the wrong thing there. Ba, ba, da, ba. Oh, you already know what it is.
Hey everyone, my name is Ashton Gleckman and welcome back to Behind.
Okay, never mind. I don't want to hear. I don't want to hear you talk. No offense. I just want some background music.
Morning.
No. Come on, guys. Stop with the... Alright, that's better. That motherfucker don't miss. It's like Snoop Dogg said. He don't miss. Alzheimer. Okay. Let's make some progress here. What did I do? Okay. Okay. Filter map. So we know for each bug, you have runs. For each run, there's an error. So you clone it, map, run. You want what's... Wait, what? Oh, filter map. Okay. Basically, if the thing is none, then it will be removed. Meaning, unless if there's no error, then it gets skipped over. I'm just trying to make sure that my thinking process is not wrong here. Okay, so this one here, it's only gonna return stuff that can be passed into a number. Sorry. And so this will be skipped, and then 5. Then you get to the end. Yeah. So here, so either you have a run, so yeah, again, just to decrease the volume there a little bit. So if there is an error, then keep it. Otherwise, eject, as in don't include it. Okay, and then for the ones that do have an error, unwrap it and check if it has the filter. So you're filtering for runs, for bug runs that have the particular filter. You're only interested in basically running another test for those specific bugs. And then map that bug run to CLI options. So for each bug, you're looking for the corresponding you're filtering all the bug runs. You want all the simulation options for the bug runs. Well, if it's a bug run, then it probably has an error. So this is a little strange. I guess it's a defensive programming thing here, because I would assume that, well, yeah, in theory I would assume that if you have a bug run, then there is an error message, but I guess you can't necessarily make that assumption. Okay, so you collect the CLI options for a given bug and its runs, and then you just change the seed and keep everything else the same. Wait. Huh? What is load? Okay. So if you pass none, what does that mean? That means you don't get to choose the plan. It's just gonna pick one for you, I guess. This is a little strange to me. Why would this already not be the case? I mean, these simulator CLI options are derived from a given bug. So why would it be different? It's an interesting choice. Let me see if I can ask the thing. Why do we need this? Considering that the runs, the extracted runs are for the bug in question. So shouldn't the seed and load attributes already be the same as the bug which is used to yeah, it's the bugs. Like what am I missing? Oh my god, this thing is going on and on. Okay, in essence, dude, this guy went through all this only for me to only read this part. In essence, the goal of this code block within the test filter is to run a test scenario for a non-loaded bug. It takes the general CLI confirm from the past failing. So it might be one of my two operators failing or concurrency, but override the seed and no parameter to strictly focus the resolution on the plan deterministically generated from the loaded bugs canonical seed. It's preparing zero, so the testing main. Download a plan string and file. I don't think this helps.
we change things if we do it different. What's happened's happened.
Hmm. Wait, what? Which one's the exact website that we use when the particular bug run? Okay. Alright, so there's the bug run, which I guess owns the seed. No, it does not even own the seed. What the fuck? No, it does, cause of this, yeah. Oh, but yeah, okay, it can be none. All right. Wait, so the seed of the loaded bug can be different than okay. I guess now I'm wondering, how do you associate a previous bug run with subsequent bugs if you're not using the seed? Well, I guess technically, purely from a practical standpoint, you can use different seeds to simulate the same bug, or run simulations that ultimately fail because of the same bug. And so we still need a way to communicate the fact that it is in fact the same bug. So is that via the interaction plan, or a combination of the interaction plan? Well, no, because the same interaction plan can lead to different bugs given different seeds, or even the same seed. No, well, different seeds. Yeah, I'm not sure. Like, I'm trying to picture in which case the seed here in the bug run is actually different. Except for, okay, maybe it was never specified. But assuming that they're both the same, I mean, assuming that this is specified, the seed is specified in a simulator CLI options, why would that seed be different from its parent loaded bug? Can a bug run belong to multiple loaded bugs? Basically, given two loaded bug instances, can they have the same exact runs vector? With different seeds? Actually, let me ask that too. Wait, so can you have two different instances of the loaded bug struct with different seeds that share the same runs vector, as in identical? Come on. What's taking so long, man? Come on, man. What's taking so long? Okay, let's see. You're asking a great question about data ownership and sharing. I don't know if that's what I'm asking. This is not really about the raw semantics of ownership. I'm talking about the logical constraints of a loaded, whatever a loaded bug is, and its bug runs. I'm not really discussing the semantics of data ownership here. Okay, well, let's see. In this structure, the runs field is of type. Gosh, I really hope this video doesn't get some sort of copyright strike, because I am playing a lot of this music, this soundtrack stuff. I don't know how YouTube feels about that. But I like it though. If they don't mind, I think I'll do more of this, because that's usually what I do. I haven't done that on streams for the most part. I feel like I should, especially for late night streams. And it actually helps me stay more focused and less likely to wanna hit the sack. Anyway, this way without. What is no. See, this is not. Oh boy. No, I didn't say share. I literally just meant in terms of value semantics. Can two separate loaded bugs have the same like oh this thing does not understand me. I did not ask the question with a lens of with a Rust data ownership semantics lens. I meant more in terms of logics, in terms of the internal domain logics, logic of the simulator. This was a follow-up question on the what was the follow on the need for resetting CLI options seed. What is it? Was it bug seed? Yeah, I mean that part I get. That it might be none, which I guess is weird, but possible, which means that it does make it for soundness, for the sake of correctness. This here makes sense. But is it ever the case that if it's not none, right? If it's not none and it's something else, can that something else possibly be different from this here? I guess that's the crux of my thinking here. It shouldn't be. Like logically speaking, it shouldn't be. If it is, then I have yet to understand why. Yeah. Where is it? Where was I? Okay, without a specific seed, then a random seed will have been generated internally at the time. This random seed will have been used to create the interaction plan for that specific execution. The same random seed would then become the bug seed for the newly discovered loaded bug. Okay. Alright. Okay. In this case, it will be none, and it will be the actual seed used. Okay. Correctly populate the seed for the retest. If the original failing run was initiated with seed, then run will also be okay. Alright. Okay. Well, at least Gemini 2.5 Pro agrees with me, assuming that we're not both lacking some additional context. I think this confirms, well, this here confirms my understanding of what's happening. So yeah, so really it's because of this here, the fact that the fact that the original run may have a non or an empty seed requires that here we actually ensure that that's not the case for us trying to rerun using the same simulator parameters. Okay. Well, that took a while to confirm. Anyway, so now we have the bugs. Sort. I'm guessing they've implemented the odd trait. No, they did not. Then how doesn't know? Am I crazy? Oh no, it will be for this. Oh, okay. I think I just derived it. No, but seriously, I mean, this is magic now. What, how did it derive the odd for this, for that struct? Can you, explain how the simulator CLI struct has an automatic odd implementation trait? I know that it is declaratively specified via the derive macro. I'm just curious about the actual guiding principle for the actual implementation, which is automatically handled by the compiler. Field by field comparison. Okay, well, field by field. It's just, I don't know. I feel like if there's a lot of field, you might as well just apply some sort of, maybe implement it yourself so that there's less magic going on. Because this kind of thing can break some assumptions that people make about how things are supposed to, especially because our brains think sequentially. Yeah, depending on the composition of the struct or whatever object is being sorted, to have the ordering trait be automatically implemented for you can possibly yield behavior that you did not, or at least in the sorting, the output of the sorting may yield an outcome or an output that you don't necessarily want. Anyway, blah blah blah, dedupe. So removing duplicates, that's pretty straightforward. Testing main. So I think we got here, but then we had to go back to understand some stuff. Anyway, but base load. Last execution. Okay, so execution, connection index, and correction index. Okay. Oh, okay. Yeah, I think it was one of the earlier stuff that we saw with all the path stuff. Okay, so you have the paths. I think I need to come back to this at some point. Well, let's just go through this function here first. Put it in watch mode, then you do that. Otherwise, for different, you do differential testing or simulator. Okay. So I think the first one to look at will be setup simulator. Backbase. Ooh. I think I may need to go use the rest of. I think I can just leave the music playing. And I'll turn off my mic. I am back. I am back. Alright. Doom. Doom, 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 doom. Doom. Yeah, I feel like this video is it's gonna get some sort of strike. Doom. Load. So I think this is saying if you should load a particular interaction plane. So you get the bug. Alright, let me see. Why is setup simulation being called again? Okay. Oh, okay. Wait, so you want? So they have both the a plain text version and a JSON version. Magic number. Oh, no, never mind. It's a percentage. Ethics. It's not used to me what that means. I understand generally speaking what ethic is in a simulation. Oh, okay. No, I get it. It's the number of loops. Oh, well, steps. So it takes. Okay. Okay. Oh yeah. Probably want to do this. There's probably some sort of power of 2 thing, starting from 4 kilobyte or kibibyte, I guess. Similar to I/O. Oh, the rabbit hole. I think I need to okay. Well, I guess there's quite a bit in the simulator environment. But we have a very basic idea of what it looks like on the inside. Okay, so we have that, and so we're returning the seed, the simulation environment, and the plans. The plans. Well, really, it's just one plan. Here that is. So this branch, okay, when there's no loading of existing interaction plans, okay. Losing some steam here. My eyes are getting a little heavy. So either you're loading some interaction plan from storage, or you're generating a new one. Max connections. We'll just, for now, just say the plans are being connected instead of trying to go see the specific implementation of the interaction plan struct and all its methods. We'll skip that for now. The ending is basically the same as the ending. Yeah. Okay. Whatever it was to play. Okay, so to run a simulation, you need the simulator environment, the plans, and the last execution. I'm guessing an execution is just really the output of executing a single interaction plan. So you have the plans for each one, you have the plan state, you have the stack, interaction pointer, secondary pointer. Okay. Okay. Actually, no, never mind. I was gonna change the music, but I like this particular part. Don't need you. Come on, stop it. So you want all the states, turn all the plans into plan states, execute plans. Is execute plans in here? Okay, no, it's all the way in here. Clear poison, what does that do? Oh, right. Okay, poison. You have to manually get yourself out of a poison state. Okay. Won't be able to go through exit plans this evening, but so this really is the workhorse. Everything else is just ceremony at this point. This is where the real work gets done. So I think that's what we're gonna focus on tomorrow for the most part, I think. Sandbox result, that's not a thing. So that's what that was set up. That's what I went to look into. Wait, no. It was this and then something else that got called and we followed. Run simulation. Okay, never mind. Yeah, run simulation. Watch mode. Differential testing. Okay, let's see what the watch mode gives us. Okay, channel, sender, receivers, blah blah blah. Watching, so the plan. Excuse me. So basically, whenever there is an event, I will just send it to this. Watcher watch. And the path to the file to wash. Recursive mode, no recursive. If it's just a file. Directory, block forever. Use the command. Okay, so the event is either a success or an error. If it's an error, just do the thing, print an error. Okay, so we're comparing. Okay, that's actually helpful documentation. the whole compute via diff thing. Okay, so environment for each channel. Oh my gosh. Okay. Oh, that's stuff that we already have. But why is it getting this watch on? Wait, that's different for the... Yeah, it is different from the... Yeah, never mind. Best execution. Doing my transfer results correct. Succeeded. Okay. Oof. I was hoping for something less. Oof, okay, yeah, no. I was gonna say that, I'm gonna go through the run simulator right now, but yeah, that's not gonna happen. In fact, I think we've reached our stopping point. Yeah, I think overall this was a good enough introduction to the I need to deal with this before tomorrow's stream, hopefully. Yeah, we had a decent introduction to the simulator. Obviously, for the most part, we've been looking at the main.rs where everything gets bootstrapped, and thing that at the top level runs the simulation. Nothing insurmountable at this point to understand. Yeah, I'm looking forward to learning more and more about the simulator. I think, with this particular series of videos looking at the simulator on this code base, I think the ideal outcome is that I make an attempt to do some sort of rewrite, maybe a much more simplified version, which may not even be worth anything. A much more simplified version using lingua franca instead of lingua franca with Rust as the target language. Although, if I want to make things interesting, I could use Python, TypeScript, I don't know, C++. Who knows? Yeah, we'll see. Anyway, so yeah, right now we're probably gonna do this for the rest of the week. looking at the code for the simulator, and then next week we'll take it from there. Anyway, this is it. This was a pretty long stream, and my brain is ready to just exit. It's been a long day. If watching this was interesting or useful in any way, please do like and subscribe, and I'll see you around. Have a good night, or I don't know, good day, wherever, or